Hi everyone, this video is on exercise 12 of question 1, and in this video I'm going to do parts A and F. So this is a very typical question from this chapter, and we have the equation. So this is the equation of the curve in part A, and then typically we are given a point and then we are simply asked to find the equation of the tangent to that point. So let me remind you that in order to find the equation of a tangent, you need to have basically the coordinates of the points in which the tangent line passes through, and also you need to have the gradient. So if you have these two, then you can find the equation of the line or the tangent. So in part A and most questions like this, we are given the point, so we don't have any issues with that. But there is a second component that we need to have, which is the gradient. But in this case, and again, most cases, we don't have the gradient. And that's our task, to find the gradient. And as what we did in the previous exercises, we are going to repeat the same thing in order to find the gradient. So if we have the equation of the curve and then the point, any point on the curve, we just need to differentiate the equation of the curve, and then we substitute the x coordinate of the point into the derivative equation to get the gradient. So let's do that. We first find dy by dx. So we get 2x minus 7 because 10 differentiates to 0. Now we want to know what's the gradient when x is equal to 2. So we always use the x coordinate. So in this case, dy by dx is equal to 2 times 2 minus 7. So the gradient is equal to minus 3. So that's the gradient of the tangent. So this is the gradient of the tangent, and also the gradient of the curve at that point, obviously. Now we also have the point, the point that the tangent passes through. So we can now use this general form of the equation of a straight line, which is y minus y0 is equal to m times x minus x0, where y0 and x0 are the coordinates of the point. So let me also remind you that many of you might be asking, why can't we use the form y is equal to mx plus c, the form that you used to use in GCSEs. So if you want to use this form, the problem is that it takes longer if you want to use this formula. And also in some other questions which you will see later on, using this formula is much better. So this is like the proper and standard way of doing this. So this was a very simplified version that you used to use in GCSEs. So in this case, so we just substitute basically the coordinates and the gradient. So the y coordinate of the point is just 0, and then the gradient is minus 3, and the x coordinate is simply 2. And now y is equal to minus 3x plus 6. So yeah, this is the equation of the tangent to the curve at the point 2, 0. Right, now let's do part F. So we have the equation y is equal to x squared minus 7 over x squared and then we want to find the gradient, the tangent at the point 1 minus 6. Okay, so again, the approach is the same. We just need to differentiate and find the gradient, and then we use the formula to find the equation of the line. There's only one thing that we should do before finding the gradient, and that's just rewriting the equation of the curve in a nicer form such that we can differentiate that. So we want the equation to be in the form x to the power of n. So in this case, the first term is fine. Now for the second term, we will write this as x to the power of minus 2. And now it's in the form of x to the power of n, where n is an integer in this case. So we now can find dy by dx, which gives us 2x minus, so here minus 2 times minus 7 is 14, and then x to the power of minus 3. Okay, To find the gradient, we substitute the x coordinate into this equation. So when x is equal to 1, divide by the x is equal to 2 times 1, which is 2, and then 14, obviously, times 1 to the power minus 3, just 14. So, and the gradient is equal to 60. So this is the gradient of the tangent line. So this is the gradient. And now we just use the formula again. So y minus y0 is equal to m times x minus x0. So we just substitute. Y0 is the y coordinate, which is minus 6. So we have y minus 6 is equal to m, which is 16. And then x0 is 1. Okay, so this gives us y plus 6 is equal to 16x minus 16. And therefore, we have y is equal to 16x minus 22. So this is the equation of the tangent at the point 1 minus 6. Alright, that's it for this video, and thank you for watching.